Hi, in this tutorial we're going to see how to create this hexagonal sphere which has some effects like displacement, rotation, Fresnel, as well as noise texture to handle the frequency of the distortion. Now in Blender I'm going to delete the camera and the light, select the geometry and delete all the vertices. Then I'm going to apply a new geometry nodes modifier, then add the node isosphere, the node dual mesh, and finally split edges. 4 subdivisions are good to me. Now I go to the UV editing tab and convert to mesh. Then I go to the UV menu and reset so I get the hexagons, and I am going to select similar by polygons sides. Now I move the hexagons to the bottom and I can manipulate the pentagons if I select all the geometry. So I am going to match them by the side, and that's okay for me. I'm going to fit in the UV space. And that's okay. Now I'm going to the UV menu, export, UV layout, give it a name, and save it for a later use. I will also export the sphere in GLB format with the name XSphere, and I will export the selected objects. Now in Krita I'm going to import the UV layout. I am going to create a new layer and call it background. Fill it with the background color and name the original layer UV. I create a new vector layer, and using the polygon tool I'm going to draw the polygons using the UV layout as a guide. Now I delete the UV layer and add a layer style with a black overlay color with 100 opacity, then the stroke effect inside, and with blend mode normal, and with a size of 30 pixels. And now I'm going to export it as mask border. And now it's ready. Now in Godot I create some folders like models, shaders, and textures. Then I import the model of the sphere, reset the transform, and now I import also the mask. In addition, I will create a new shader include. I have to save the scene, and the shader include has some essential functions like remap, both for floats and vector 2, saturate to clamp from 0 to 1, rotation to apply a matrix rotation to a vector 2, and finally the Fresnel function. Now I'm going to make the sphere scene local and extract the mesh and then rename it. I will delete the original node. Now I'm going to add a new material shader in material override and create a new shader. I'm going to include some variables at the top like Fresnel, border color, border mask, Fresnel pow, rotation, panning, and displacement. I'm going to adjust the color once, plus I'm going to add the mask texture. And then I'm going to add a noise texture for both the distortion and the colors. I'm going to use the Perlin noise option, as well as disable the FBM and change the noise frequency. Now I am going to include the function file, and in this case I am going to use the coordinates of the normals to be able to map a texture in this spherical shape. I am going to take the x and y coordinates of the normals and remap them to the range of 0 to 1 using the remap function. Now I want to show you quickly how the UV space obtained through the normal coordinates looks like. Here it is. It's obvious that it fits the spherical shape because of the orientation of the normals to the mesh faces. I'm going to delete all the above, and now I am going to create a variant for noise. Now, I am going to assign the noise texture to the variable, and with it, I'm going to displace the vertices using the direction of the normals and multiplying by the floating value displacement that comes from the uniforms. You can notice the displacement thanks to the noise texture. I will apply now rotation to the coordinates using the rotation function. The time and the uniform rotation variable. I will also offset the coordinates with the panning variable. You can see the movement. And now let's go to the fragment shader, and I will start by defining the border color, multiplying the border color variable by the border mask. This mask is obtained from the texture that we created in the Krita program. You can see the result in albedo. The second color comes from the Fresnel color multiplied by the floating value of Fresnel, which is basically the dot product of the normal and view vectors. The resulting color will be the maximum of the two colors. The final color is starting to show. Now, I am going to assign the emission to the resulting color multiplied by a constant. You can assign a uniform, of course. And with the emission, you can notice that the mask has some glitches that I will solve by removing the compression. It only remains to assign the alpha channel by multiplying the edge mask by the noise and adding the Fresnel mask. I notice some jumps in the deformation, and this is because I didn't set the seamless mode in the noise options. Also, I changed the color a little bit. Now, I am going to assign an environment node, and I am going to set an opaque solid color. In addition, I'm going to activate the options of the glow effect. I adjust these options basically by trial and error. I like this result, but I want some more contrast in the noise mask. So I am going to apply the pow function to the noise, and you can see the difference. I like this way. Now you can see more transparency. You can play with all the options, and that's it, the final effect.